Okay, guys, we are now going to move to the next section, which is 1.7, graphing quadratics. Few things we need to get through before we can get to the problem. We need to define some stuff. First thing we need to define is the axis of symmetry. The axis of symmetry is very simple. It is a vertical line which goes through the vertex. All right? Now, to find that axis of symmetry, remember from last section, we have ax plus by equals, or plus c equals 0. Ax squared plus by plus c equals 0. So, to find the equation for the axis of symmetry, that's an O. Okay? We use a very simple formula. It's x equals negative whatever b is over 2a. And that is your axis of symmetry. Now, whenever possible, you're going to put these things in this form. Y equal a times x minus h plus k. That is an h. Gosh darn it, I'm sorry, guys. I didn't want that. There we go. That form right there is what you want. Now, there's a few things to know about that form. Number one, the vertex is HK. The axis of symmetry in this form is very easy to find. That's the vertex. The axis of symmetry is just x equals h. It's whatever that x coordinate is. There you go. Now there's one other thing this thing tells you. Most of you should know this from Algebra 2. Some of you don't. That's okay. We'll get her figured out. Let's use orange. We haven't used that yet. So, look at A. If A is greater, that's an ugly orange, is greater than 0, it opens up. So, it's a parabola that goes this way. If A is less than 0, it opens down. Like that. All right? One other thing you need to know before we do some examples is what is called the determinant. And it determines some things. And it is part of the quadratic formula. It is the part that says b squared minus 4ac. That is the determinant. And what it does is it determines the number of x-intercepts. Or roots, or zeros. Okay? So, let's use this color first. If the determinant is greater than 0, then you'll have two x-intercepts. If it is less than 0, wrong. It is equal to 0, sorry. Then you have 1 x-intercept. And if, why didn't my color change? It is less than 0, then you have no x-intercepts. And that is what the determinant will tell you. Okay? So now, let's do an example. They're going to give you this thing. They're going to say graph the following. Y equals x squared minus 6. Well, we know we have to graph it. So let's draw a graph over here. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All righty then. Remember, the function that we're looking at is ax squared plus bx plus c. So the axis of symmetry, that's the first thing we need to find here. Okay? Boom. The axis of symmetry. That's negative b over 2a, which is negative b. What's b here? Oh, I copied the problem wrong. That's 6x. No wonder I was looking at that thing like it was all goofy. Okay, so negative 6, that's 6 over 2 times a, which is 1. 2, the axis of symmetry is 3. So I'm going to go over here to 3. And the axis of symmetry is always a vertical line at x equals 3 on this problem. It's always a vertical line. Cool. The next thing we look at is, okay, if x is 3, what is y? Well, I plug it right into here. Y equals 3 squared minus 6 times 3. Well, that's 9 minus 18, which is negative 9. Well, here's my x coordinate. Here's my y coordinate. So my vertex, okay, the vertex has got to be 3, negative 9 on this one. So I'm at 3, and I go down to negative 9, which is right there. Boom. All right. We got to start. We got our vertex graphed. What else can I use? Well, we know how to find the zeros of the function, don't we? That means where it's going to cross the x-axis. So I'm going to say 0 equals x squared minus 6, x, and solve it. Well, here, all I'm going to do is factor out an x, set both of those equal to 0, solve, go back to my other color, and I can say at x equals 0, I'm right here. And at x equal 1, 2, 3, 4, 5, 6, I'm right here. I draw that one. I draw that one. And there's my graph. Now what I want you to notice is, you notice that from here to here is 3, and from here to here is 3. That's why it is called an axis of symmetry. It's symmetric about that axis. It's the same distance to the right from there as it is to the left from there. That's why it's an axis of symmetry. Okay? So let's do one more. This one is y equals x squared minus 2x minus 7. We're going to draw our graph again. Yeah, we'll add some down there, make it look pretty. Nah, we're good. Okay. Well, to do this one, we're going to have some fun here. We are going to complete the square and put it in a different form. And I know I told you usually I only use completing the square when I'm dealing with circles. But on this one, it kind of makes it easier. So what you're going to do is say y equals x squared minus 2x, leave a space, minus 7. Well, divide that 2. Here, let me underline it. Divide that by 2. 2 divided by 2 is 1, and square it. That's plus 1. But if I add 1 there, I have to add 1 there. Okay? So now I'm going to simplify it. 1 plus y is equal to, well, that's just x minus 1, quantity squared, minus 7. Move the 1 over, and y is equal to x minus 1, quantity squared, minus 8. Well, this makes it easy. The vertex, now we know, is HK. 1, negative 8. So let's go graph that. 1, 2, 3, 4, 5, 6, 7, 8. Boom. Okay. The axis of symmetry is just x equals whatever that x coordinate is, 1. So here's my axis of symmetry at x equals 1. There we go. Now I got to go find the zeros. Well, I just set it equal to 0. Oops, that's minus 8. So I go 8 is equal to x minus 1 quantity squared. Take the square root of both sides, positive or negative. 2 square roots of 2 is equal to x minus 1. When I add 1, I get 1 plus or minus 2 square roots of 2 is equal to x. Well, the square root of 2, okay, is like 1.3 or so. 2 times that is like 2.3. And then you add 1 is like 3.3. It's like 2.7 actually, 2.8. So I go from here, and I'm almost at 3 away. So go from here and go 1, 2, almost 3. We're right about there. Okay. We'll switch. Boom. Give me that color, darn it. So I'm there. Now I just got to make sure I go the same distance the other way. 1, 2, and almost 3. There's that side. There's that side, and we are done. And that right there is how you graph quadratics. All right. So that will cover that.